Okay, so let's go ahead and start on your review. You have a p-value of 0.034. Which of the following is a proper interpretation? Well, what is 0.034? So we probably should be using that number in our answer. Now, I know your review sheet doesn't have multiple choice, but I wanted to let you see some of the options and forms of answers that I've seen. All right, one of these is correct. So it's probably one of these four because we're using the number 0.034. A p-value is a probability, and they all say probability, so that doesn't help so much, right? But what is it the probability of? Well, it's the probability if we know that our null hypothesis is true, if it's actually true, it's a probability of seeing what we saw. So the probability of seeing a sample result, let me go ahead and point our options here. So a sample result, that or more extreme. So what we saw given our null hypothesis, okay? So that's the proper interpretation. The probability of seeing a sample result you saw is that 0.034, given that the null hypothesis is true. Okay, you are performing a hypothesis test using the following significance level. Alpha is 0.05. You calculate a p-value of 0.5. So don't mix those two numbers up. They look similar, but they're switched around. So what should you conclude? So are we going to reject or fail to reject? Well, our p-value is lower than our alpha. Oh, no, it's higher than our alpha. So we're going to fail to reject. And we reject because we don't have really great data. You know, it's not great data to change our mind. We have insufficient evidence. So the main thing you need to remember is if your p-value is greater than your alpha, you fail to reject because the data is not significant and you have insufficient evidence. Okay, now you have a p-value of 0.04. What should you conclude? Well, this time it's less than our alpha. So that's surprising. So we're saying, oh, we're going to reject our assumptions. We have significant data and sufficient evidence. So if your p-value is less than alpha, that means reject, it's significant, and you have sufficient evidence. A teacher suspects a student cheated on his quiz. The assumption is, and hopefully the assumption would be, the student did not cheat. The alternate is the student did cheat. So which of the following would be a type 1 error? So a type 1 error occurs when the first hypothesis is true, but we have data that leads us to think. So let me go ahead. Those are the two that says the first hypothesis is true. But we have data that says, we think the other one's true. All right. So that would mean the teacher would conclude the student did cheat, even though he didn't. All right. So the correct answer is C. And then now we ask what would be a type 2 error. So that would mean the second one is true. All right. He did cheat. Okay. But we think the other one is true. The data, we don't have sufficient data to say, yeah, he did cheat. We can't come to a conclusion on that. So we have to stick with our assumption, which is probably what you would want a teacher to do, is if they don't have proof that you cheated, they can't say you cheated, right? So that does happen. Okay, but I fix that because everything I do is randomized, so it's possible to cheat. Yes, I know, but it's not as easy, no. All right. Hypertension is defined as blood pressure reading over 140 millimeters mercury systolic and or over 90 millimeters mercury diastolic. Hypertension, if not corrected, can cause long-term health problems. In the college-age population, 18 to 24 years, about 9.2% have hypertension. That's a lot, actually. Suppose that a blood donor program is taking place in a college dormitory this week. Before each student gives blood, the nurse takes a blood pressure reading. Of 191 donors, it is found that 28 have hypertension. Do these data indicate that the population proportion of students with hypertension during final exams week is higher than 9.2%? And we're going to use a 5% level of significance. And the easiest question on the quiz, what is the level of significance? Well, it's the alpha in decimal form. And here they gave it to us in percent, so change it to 0.05. So Now they say state the null and the alternate. So what's important to know is we're trying to see if the data indicates something. All right, so first of all, let's start with the null. The null is the beginning assumption, and it always has an equal sign, so we're going to cross this one off. We're wondering if the data indicates that it's higher. So that means we're going to go to the right, and we're going to pick P, the proportion is greater than 0.092, okay? So the initial, the null is P equals 0.092, and the alternate is P is greater than 0.092. By the way, they use the same wording for the null here, but they tend to use H1 for the alternate, whereas I tend to use HA. Same thing, just slightly different notation. What sampling distribution will you use? Do you think the sample size is sufficiently large? So we are working with proportions. That's always the standard normal, all right? So then we just need to make sure that our successes and failures are at least 10, and they are. So it's the standard and the normal, so since both successes and failures are greater than 10. All right, that is the answer on your quiz, so please get it right. What is the value of the sample test statistic? So we're going to have to go ahead and use the Statlet. So you're going to go to one categorical variable, single group. Go ahead and you're going to have to put your data in. So we have hypertension and not hypertension. And they told us there are 28 out of the 191. So you can see there's a 28 out of the 191. The next one is not the total. It's what's left over. So 191 minus 28 is 163. And then I go to the very bottom of the screen where it says perform inference. Make sure I pick a one sample z-test, and then make sure the alternate. So the alternate is that P is greater, not P hat. P is greater than our hypothesized percent. Now, by the way, this says percent. So let me highlight something here. Depending on your settings, if your settings are percent, this is percent. Now, it is possible to have this where it says proportion. If that's proportion, then this is 0.092, okay? So again, let me get my pen, just so you can see. Wish I could type on here. If proportion, proportion right here, sorry, I'm writing because I don't, then use 0.092, 0.092, okay? So just be careful with that, all right? So you can do this in your settings. If you have a problem with it, show it to me during the quiz. If I'm there, I should be there because I'm letting you take the quiz. And I can point out, hey, you're in percent or proportion. So that's usually what's going on there. Okay, so then your test statistic is that Z, it's 2.611. And your p-value, which is the next question, is just that other number. So actually, I think on the previous one, I had 0.0. I must have used different settings on my decimals. So here you can see I'm getting a p-value of 0.0045. That's equivalent. That's D. It's right there. So if you had gotten 0.005, again, that depends on your settings on your Statlet. So make sure you have enough decimals. Okay, sketch the sampling distribution and show the area corresponding to P. Well, we're going to have a normal distribution, and the shading should match the direction of your alternate hypothesis. Since the alternate says greater than 0.092, it should be shaded to the right, okay? The area should also be similar to the p-value. So 0.0045 is a rather small proportion, so it should be a very small area being sketched. Okay, recall that alpha is 0.05 and your p-value is 0.0045. Based on your answers, will you reject or fail to reject the null hypothesis? And are the data statistically significant at the level of alpha, in this case 0.05? So, first of all, we're going to reject, right? So we have two options here. We're going to reject because our p-value is low. And we only reject when we have statistically significant data. So the correct answer here is C. So at the 0.05 level, alpha, we reject the null hypothesis and conclude the data are statistically significant. Interpret our conclusion. Well, we only do this because we have sufficient evidence, all right? So we look for the ones that say sufficient evidence, and then the evidence is always for the alternate hypothesis. The alternate didn't say equals to, it said higher than. So the correct answer is A. There is sufficient evidence at the 0.05 level to conclude that the true proportion of donors with hypertension is higher than 0.092.